With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, so the question is asking that we have been given this paragraph that the molecules which are electron deficient having tendency to form back bonding, in which transfer the one lone pair of electron from filled orbital to an atoms to have vacant orbitals of the adjacent atom, while some electron deficient species which are not capable to form back bonding, then driving force occurs for the dimerisation or polymerizations to achieve the octet temporary or permanently by the monomeric species. Now, question is which of the following readily gets combined with the Lewis base? These are the Lewis base. So, which of the following will combine with the Lewis base? So, first is obviously not the answer, second is not the answer, and fourth is not also the answer. Why? Let me explain. So, basically, first is basically CH3, CH3. So, this octet is already completed. Octet is already completed, so vacant orbital is not there. So that means that will not react with the Lewis acid. To react with the Lewis acid, it should have vacant orbital. What about this I2Cl2? So basically I2Cl2 is formed in between ICl3. Two ICl3 compound will come together, and this iodine already is completed its octet. Then also it is forming a dimer, means lone pair of this chlorine will be donated here to form a coordinate bond with this iodine. Here also same scenario will be there. Lone pair of this chlorine will coordinate with this iodine. Here coordinate bond will be formed because here vacant orbital is present on the iodine. Here also vacant orbital present on the iodine. So already this iodine is completed its octet, so it does not have a vacant orbital to gain this Lewis basis. So this will not react as well. So that is not the answer. But what about this B2H6? B2H6 is basically electron deficient compound. B2H6 is electron deficient compound, and this is basically this is the dimer form of BH3. What happened? To temporarily gain its octet, its dimer form is formed because BH3 is basically this is basically a electron deficient compound. So temporarily this bond is shifted to this this boron so that it can gain its for some times, for some moment, not time, for some moment it can gain the it can complete its octet. In the same way, the hydrogen, this hydrogen will be bonded pair, this hydrogen will be shifted to this position to again the to complete the octet temporarily. So this is basically electron deficient compound. So that can react with either NH3, we can take C2, CH3, NH2, and we can take third compound as well, that is C5, H5N. So here lone pair is present, so it will donate its lone pair and it has a vacant orbital, so it will react with this one. Okay, so here reaction is possible in the third case. In the fourth case, again, because of this polymerization, what will happen? First of all, it will have a vacant orbital. In that way, means it has a vacant orbital. Another beryllium will take come here, and it has also vacant orbital. So it is basically electron deficient compound. But after participate in the this polymerization, what will happen? The lone pair of this chlorine will be donated to the vacant orbital of this beryllium. So here coordinate ball will be formed. In the same way, here also coordinate ball will form. Here also coordinate ball will form. In the same way, as we can see, here also coordinate ball is formed. So as we can see, this boron is completed its octet. In the same way, all the boron here also one coordinate will be formed. In the same way, this chain will be pushed. So in that way, the beryllium is completed its octet by gaining the lone pair from the chlorine. So in that way, we can say it is already so this beryllium is already completed its octet. So it will not react with this NH3. That means base. So only third is the answer. So I hope you understand this concept. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.